Hey YouTube, Jay Kilroy back here after what seems like endless weeks of bottomless work. I guess I shouldn't complain. Got a project. Sight glass. This is a sight glass, one of two of this size, off my Pacemaker, and they had a thick acrylic lens in here, like a 1/4 inch thick acrylic lens that had become really scratched. And even the back of this one had got paint on it, and someone had tried scratching the paint off and like just scratch it. It was completely not usable. So I want to make some new sight glass lenses, 2 new sight glass lenses today for the Pacemaker. Matter of fact, I'll tell you what, I'll take you over and show it to you right now. Let's go for a little walk. Right here. That is sight glass. It's not a level glass, it's an oil flow glass. So when the machine's running, oil pumps out of this pipe against the glass, drains down the tube. And you see I've cleaned the interior of this out. I've lightly dusted it with some flat white paint. Here's the other one that's the same size right here. Now that is a level glass. That shows you the level of the oil in the headstock. I can't take that one out until I drain the oil out of the headstock, and when I do that, I'm gonna drain it out. I'm gonna take the top off. I'm gonna clean it out. I'm gonna do a video on all that. But right now, we're gonna make a couple of new lenses for these sight glasses. There's other sight glasses on the machine, but there's only 2 that size. Whoop. So anyway, this is the bezel. Actually, one of the sight glasses, an old cork gasket on top of it that has achieved the consistency of hardened steel. The screws used to hold these in. These rather banged up little Phillister head flathead screws, 1/4 inch 20 in size. So we're going to drill the holes here on the mill. I'm going to demonstrate using the bolt hole pattern functionality of my DRO. I have the usual Sino, I don't know how you pronounce it, Sino DRO. Got mine from Shars. They're sold through several manufacturers. The documentation tends to be somewhat of a challenge, but if you figure it out, it's a really useful piece of equipment. So anyway, I'm going to use the bolt hole pattern section to cut some sight glasses. Here's the material in question we're going to use. This is a piece of scrap 1/8 inch lexan from a previous project, and we're going to cut. I'm going to cut 3 while I'm at it, you know, in case I scrap one and just to have a spare. And so this is what we're going to use, just 1/8 inch clear lexan. Let me readjust the camera so we can get a little more detail on the scene here. Alright, here's our bezel, and move that out of the way. This is our piece of material, obviously bigger than I need. How are we going to hold this? Real easy. This is a piece of scrap 2x4 that I'm going to clamp in the vise. What I'm going to do is I'm just going to take some sheetrock screws, and I'm going to put some sheetrock screws in here. This stuff, you know, lexan's tough. It's very soft. Therefore it's pretty darn tough. Let's try to get a couple more in there. One more. Try over here. it in between. Alright, so basically we're just going to clamp this 2x4 in the vise, let it rest down on the vise edges. We're going to cut our lenses out of this space in the middle here. There's your diameter, so I should have room for 3 of these in here. And so let me go ahead and get set up on the mill, and we'll go ahead and drill what we're going to do is we're going to establish 3 centers, just random centers. We're going to establish 3 centers, and then I'm going to drill the 3 bolt hole pattern around each center. Then we'll go back to each center and cut the disc out around the already cut holes on those 3 just arbitrary centers. So that's how we're going to do it. So let me go ahead and get this set up in the machine, and we'll drill the holes, and I'll demo how the bolt hole pattern functionality works if you don't already know on the DRO. Alright, we're set up in the mill here. We got our piece clamped down. We want to establish, again, we're going to establish an arbitrary center. That looks like about right on the Y. And then I want to set up my first here. Come back just a little bit more. So let's see what that looks like. That's a little close to that screw, so let's come back this way a little bit. I got to go get the hole cutting bit around that. That looks pretty good. So we're going to establish this as our 0, 0 location for our first lens that we're going to cut out. Then we're just going to do, well, we might not be able to get 3. I don't know if I'll be able to get, probably so. Then we're just going to do 2 more across this block. And again, with just arbitrary center locations. So I'm going to write down my first center, 0, 0, and go ahead and enter X and Y, 0 my DRO, and then we're going to cut our bolt hole, our screw hole pattern right here. Alright, we got our piece mounted, we got our arbitrary location of 0, 0 chosen. We have our DRO zeroed, we're going to do our bolt hole pattern. So we're going to enter the bolt hole pattern mode, PCDXY, we're going to hit enter. Center position 0, 0, that's where we are, 0, 0. So we're going to hit enter, we're going to hit down arrow for the next step. Diameter. I've already calculated out that the diameter of the bolt hole pattern is 1.73 inches. The OD of the piece is 2.23, and the screws are on a 1.73 diameter. Enter next step. I have a down arrow for next step. Number of holes. This is a little bothersome, but I'm entering the number of holes is 3, and you notice it doesn't display anywhere. And then you got to hit enter. No real confirmation that anything's happened, which is kind of, you know, nasty, but it works. Hit down arrow. Starting angle, we're going to start at 0 degrees. And then the ending angle is going to be 240 degrees. That's the last hole position. Going to hit enter. Going to hit down arrow for first hole position. So what you do is you zero your DRO. So I don't need to move my Y, I need to move my X. There we go. I'm going to go ahead and drill that hole. Then you hit down arrow again. Okay, this tells you how to get to the next hole. So I need to come over till that's 0. And then 0 the Y. There you go. Drill that hole. Hit down arrow for the third hole. Okay. Leave the X in a static position. Move the Y. That'll read 0. There you go. Drill that hole. Alright, so we've drilled all 3 of our holes. You want to exit the program for doing bolt holes. Just hit the button again. Okay, you're back to your regular DRO functionality. Now let's check the holes out. Alright, there are 3 holes. And let's raise the spindle up. Get that out of the way. Drop my bezel down here. And it's looking pretty good. We are lined up on our bolt holes there. So I'm going to go ahead and knock one more of these out, and then we're going to use our arbitrary centers to come back and cut the disc out, and that'll be a separate using some different tooling for that. So let's go ahead and get set back up. Alright YouTube, we've drilled the bolt hole patterns, screw patterns. The piece is still in the mill. Now we're going to discuss how we're going to cut the discs around the mill, around the bolt holes to match the bezel here. And obviously there's a variety of ways you could do this. Probably one of the most inexpensive ways you could do this would be the hole saw, if you happen to have a hole saw that matched this diameter. 2 1/4 in this case, OD would be close enough, but I don't have one that size. And what we're going to use is a ValCut hole cutting or trepanning setup. This is a drag cut style trepanning setup. Get some parts out here, and we're going to discuss how this the ValCut trepanning setup works. Alright, the ValCut trepanning setup is a drag cut style setup. You see this angle here in the end of this cutter bar. This bar mounts the cutter. The cutter travels in this direction, and it is mounted at a backward angle, and then the cutter, the ValCut cutters, here's one here, see the orientation here. The ValCut cutters are a complex grind. Certainly wouldn't be something that I would want to try to reproduce by hand, even though I'm not saying someone with a tool cutter grinder certainly could do it, but this is the orientation as the cutter moves across the work. You see the cutting edge is drug across the work and cuts down into the work. And you see this cutter has see the angle across this face, right? The low end of this cutter edge is on the outside. So this cutter is designed to cut clean holes. And you know this because of the way it angles in. It's going to leave an angled cut surface on the disc that you cut out of the hole. And let me get out a different style cutter. This cutter, this cutter here, hello, focus, is designed to cut. You see the difference here. The low point of the angle is designed to cut a clean disc and leave the tapered side on the exterior. So this cutter here cuts a clean hole. This cutter here cuts a clean disc. Obviously, in our case, we want the disc. We don't care about the hole. So this is the cutter we're going to be using. Hello, focus. Alright, so had a little focus issue there. So what we're going to do is we're going to use this short bar. Obviously, these bars mount in here. See this screw? Screws in from the bottom. Clamps this bar in against the back of the body of the cutter. It's a very precision-made piece, and it is a very secure mount. This hole here is for a center drill if you're going to use one. Obviously, I'm not going to use one because I want the disc, not the hole. And you see the little scallop in this drill bit. When you want to take this drill bit out, you take this screw out all the way, and there's a little bar, transfer bar, that this screw pushes over that holds this bit in. So you take this screw out, and then you can just twist this and it'll pop right out. Let me go ahead and get this mounted up. This is as far as ValCut goes, you'll see if you look at these, they have different series. This is a 3000 series ValCut setup. So 5/8 inch shank. Most of them have Morris taper shanks. Some of them have straight shanks. This is a 5/8 inch straight shank, 3000 series, and it uses 5mm sized cutters. And I've got some various cutters. The cutters are unfortunately not cheap. Even the high-speed steel versions are in the $25 to $30 a piece range. This one here is designed specifically for cutting plastic, and it's actually carbide. They also come in different depths of cut. So this one is designed to cut up to 3/8 of an inch. They make them that are longer and have different grinds, different relief grinds, to allow you to cut deeper holes. And you just have to get the size cutter that fits your application. So let me go ahead and get some socket head wrenches here, and we will get this screw mounted. Alright, I got the cutter mounted in here. You see this shows you two different types of blade mounting styles. This one actually mounts in the end of the bar. The bar has a cap screw that goes through it. The bar is slit, and the proper slot is cut in the end of the bar to hold this. And this is for, obviously, you see the relief here. You can do pretty small. You can do pretty small diameters. The other way to hold the cutter is with what they call a cutter clamp, and this is a cutter clamp. And it just clamps to the bar. This is just a plain bar. Neither end is modified to hold the cutter, and then the cutter clamps here. One of the advantages of the cutter clamp method, see it says 3000 on it there. One of the advantages of the cutter clamp method is you can have two cutter clamps on a bar at the same time, and you can cut balanced with a cutter on each side. Also, you can have two cutter clamps on one side, and you can cut basically hoops out. You can cut discs out instead of holes. And you'll notice, if you look at that cutter there, look at this cutter here, you'll notice the length difference in the grind and how this cutter here is designed for cutting a much shorter depth of cut than this cutter, which has a much longer neck on it, much more relief ground into it. This is designed for cutting deeper. Again, this is the cutter clamp style, and this is the bar mounting. And I actually find that the cutter clamp side is easier to adjust. But for doing small OD, this works real well. So we're going to get set up now to measure our distance here, so that we can set the tool up for the 2.23 OD that we're going after. Alright, so what I've done is I've just slipped the center bit back in here, and we're measuring it. We want to cut a disc of 2 1/4, right? So let's look at that. We got a 2.23 basically diameter that we want to end up with, right? So how are we going to set this tool to cut that 223? We'll take 223, we'll divide that by 2, and so we want a radius of 1.115. Now how are we going to measure 1.115? We can't measure to the center, so we need to subtract half of the diameter of this drill bit, the center drill. So the center drill is where we're going to be measuring 195. So 0.195 divided by 2 is 0.975. So we take that, we take the 1.115 minus 0.0975 equals 1.0175. This is what we want to end up. My chicken scratch. 1.0175 is what we want to end up with, a radius measurement between here and this point to get our 2.23 inch diameter disc. Okay, well, once you figured out the distance you want to set this, 1.0175, and I mean, this isn't exactly what you call rocket science here, so we're just going to round that off to 1.017 and go with that. Forget the 5 out there on the end, that's crazy. What's the easiest way to set this thing? Well, adjustable parallel is real easy, or the way I'm going to do it right here is with a little stack of gauge blocks. Set that between the cutter, right at that tip. Set that there. I'm going to take this off camera while I tighten it because it's tricky. Alright, we'll tighten that up. Let's check our stack. We're right on. Okay. By the way, to get to the 1.017, I used a gauge block stack of 800, 110, and 107. That's how I got to there. The gauge blocks look nasty. It's because I keep them packed in lanolin grease for rust prevention, and for normal precision type use I would clean all this off. For this purposes right here, if the lanolin adds a thou or two, I just really don't care. So go ahead and put these up, and we'll get the ValCut mounted up, and we'll cut some disc. Alright, let's try this close-up angle right here. We've got the ValCut mounted in the spindle, and we're going to run it back to our original arbitrary home of 0, 0 for the first piece. 0 there. And 0 there. So I'm going to go ahead and lock my X, lock my Y, make sure that I don't move. Got the machine in back gear. I'll try to level this up for you here. Tricky sometimes getting right in on the action. So I'm going to run this at about 220 RPM and just hand feed, and I don't want to run it too fast. I want to be very careful as I get ready to cut out, as I get ready to cut all the way through, that I don't sling the workpiece all over the place. Not going to run any coolant, but I'm going to keep a little air blast here handy to keep chips out of the way. So let's fire in the hole. That's 200 RPM right there. Okay, just wanted to scratch it. And then let's get the camera up here. This position isn't any good. Let me get a better position. Okay, this is a much better position. You see I've done a scratch cut just to make sure that everything looks right, that I'm centered around the holes. I can lay the bezel up there and give you a little kind of point of view there. Now, this is going to cut a wider kerf. It's going to cut, you know, a 5mm kerf. And all we're interested in getting out of this is the disc, right? That's it. So, you know, we don't want the disc flying off. And I thought about running a couple of screws in through these holes here. And you know what? Nah, I'm not going to do that. We're just going to go ahead and cut. Cut and keep an eye on the piece so it doesn't fly off. Okay, you can't see it, but over here I'm starting to break through right here. I just have a little bit of depth of cut left. All right, that is close enough. Okay, there's our disc, and you see what I was talking about with the cutter. You see this beveled surface here. It's wide, 5mm wide beveled edge. This cutter is designed for cutting clean disc, and clean it is. It's a very nice clean cut. So let's move over to our next set of dimensions and cut the second piece. And I wrote them down right here. My next 0 is 2668. You gotta unlock the table first, Kilroy. Two, 6, 6, 8, and Y of, gotta unlock that too. A Y
of a 1/2 inch even. Okay, so we're centered over our second piece. Lock everything back down. Lock the X and the Y. Just don't want to bump it accidentally. And let's fire it up and let's cut our second piece. Let me move the camera around a little bit here. By the way, third piece, foobarred it. My bad. But it happens. That's why you do an extra, right? Again, we're going to do a scratch cut. Alright, that looks good. Alright, again, we're cut through there. Enough all the way around. I can clean this up, sand that up, make that fit. There's our two lenses. Let's get the camera set back over on the bench and we'll look at our finished product. Alright, move some stuff out of the way here. Here we go. We've got our two lenses. Let's lay that up here right on the bezel. And let's get a close up here. OD. Bolt holes. Everything looks good. Real nice fit. Check our second one. Again, OD, very nice fit. I'm gonna clean these up a little bit, just sand these up a little bit on the edges to clean up that cut edge where I pulled those out before they broke totally loose, so that I didn't have to go chasing them around the shop. And we'll be ready to go. All right, so let's clean these up. Just got a cheap El Cheapo file here. And I'm just going to run the edge down the file a little bit just to clean up that little burr that the cutting process leaves. And clean that up. There we go. So we are clean there. Let's skin one of these babies. Alright. So there's another little burr. Alright. I don't even know if you can see that. Let's get a little glare on it. There you go. Lexan, sight glass window. You know, made out of scrap. That's going to replace the two that I have now. And when I get around to mounting, the second one, draining the headstock, we'll do a little video on that as well. Anyway, I hope you enjoyed it. The ValCut setup is a very nice setup. It's not an inexpensive setup. Alright guys, we're done with that little project. We got sight glass lenses. So now you know how to make these. And they're pretty easy to make. Of course, having the right equipment really helps. The ValCut setup here is a very nice setup for doing this kind of work, for doing OD and ID work. Don't think you can only cut plastic with it. I've cut 6-inch stainless steel disc, got a 3/16 with that stuff, not thick, but I've cut
Stainless, cuts fine. I've cut cold roll, cuts fine. Cut aluminum, cuts fine. The drag cut cutters, the drag cut geometry is pretty amazing. The only thing to watch for when you're using these cutters, this ValCut setup, especially when you're cutting stainless, is it cuts a continuous chip. It does not break a chip. If you're using like power feed to feed your ValCut setup, it's going to make a continuous chip, and it's a limb remover, right? If you can break your cut by working with your feed to break the chip, you'll be a lot better off. Anyway, got more videos coming soon. Hope you had a good time with this one, and be safe in the shop.